In the introduction to dynamics of rigid bodies, it was mentioned that kinetics requires lesser mathematical expressions as compared with kinematics for a particle. In this video, we will learn the fundamental equation of kinetics for a particle by recalling the idea of force, inertia, and mass. Force is defined as the push or pull exerted on a particle, the only part of a force system that will cause the motion of a body is the unbalanced force we call the resultant. If in case there is no unbalanced force acting on a particle, we can say that the force system is in a state of equilibrium or balanced state. And in that case, there is no external force that will cause the particle to change its state of motion. Inertia is the property of a particle to offer resistance to a change in motion. As we have discussed, although all particles have inertia, they do not offer the same amount or degree of resistance. And lastly, mass is the quantitative measure of a particle's inertia. That is why an object's inertia is directly proportional to an object's mass. Consider this experiment. If you apply an external force of different magnitude to the same body, different magnitude meaning some are stronger and some are weaker forces, each of these forces will cause a corresponding acceleration. For every force that you apply, there is a corresponding acceleration. Dividing each force to the acceleration of motion, the ratio will always be equal to a constant value, c, as given by this equation. In this case, constant c is the measure of the resistance of the particle to be accelerated at a rate a after being acted upon by a force F. Thus, we can say that an object's mass is directly proportional to the resistance c. If you multiply the mass of an object by a constant of proportionality, that would then be equal to the constant c. Going back to our first equations, we have force divided by acceleration equals c, and that is also equal to the constant of proportionality k multiplied by the mass of the object. The units of force and acceleration should be selected such that k would be taken as unity, leaving us with the formula force divided by acceleration is equal to the mass of the object. This is the fundamental equation of kinetics for a particle, and this was also discussed as Newton's second law of motion or the law of acceleration of a moving particle. The fundamental equation of kinetics for a particle is often associated with DAlemberts Principle. And before we study this principle, let us first define what is an effective force of a particle and what is an inertia force. The effective force for a particle is defined to be the resultant of the external forces that act on the particle. When an external force is applied on an object, it will resist a change in velocity or acceleration. This resistance is called the inertia force. It is equal to the mass of the object multiplied by its acceleration. Since it is not an applied or external force, it is also called a fictitious force or imaginary force. It is assumed to act on the body for the purpose of achieving equilibrium, applying the laws of statics. The DAlemberts Principle states that if the resultant of the effective forces for all the particles of a body is reversed and assumed to act on the body with the external forces, the body will be held in equilibrium. If inertia force was a real force, then the particle would be indeed in equilibrium, and there is no motion that will accelerate the particle. That is why it is usually drawn as a vector with dashed line. Taking into consideration that a body rigid or non-rigid, is composed of a collection of particles. The sum of impressed force applied to a certain body is equal to the sum of all effective force experienced by each of the particles of that body. Using this idea and DAlemberts Principle, we arrive with the equation summation of external forces minus mass times acceleration is equal to 0. This equation is very similar with the fundamental equation of kinetics for a particle, which is written as summation of force divided by acceleration is equal to the mass of an object. Thanks for watching. If you like this video, don't forget to hit the like and subscribe button and turn on the notification bell.